Hello, welcome everyone to the fifth day or the third live day, the final day of the DSC Europe 23. My name is Zoran Stanovic. I will be the host of this stage again today. And we are starting with a very interesting presentation, at least from my point of view as a journalist. That's the innovator's dilemma, to build or not to build. It will be presented by Danijela Horak, who is the head of research at BBC. In this talk, we will delve into the evolving landscape of firms with established in-house machine learning teams and explore the critical question of their future role in the ever-changing world of AI. Danijela, please.
Thank you.
The floor is yours.
Thank you very much. It's a real pleasure to be back here in Belgrade this year as well, and a true honor to be the opening session of the third and the last day of this great data science conference. So I've given myself a very ambitious task for today to talk about both strategy and intricacies of machine learning models from the point of view of tier 3 industries. When I say tier 3, I mean tier 3 in terms of tech. So basically, tier 1 would be your firms that are pushing boundaries in AI, like OpenAI, Google, DeepMind, and so on. Tier 2 would be people who are squeezed by the regulators and have a lot of money to throw at the problem like investment banks, like hedge funds, fintech firms in particular. And then tier 3, where I think we kind of stand, are the firms that are just about big enough to have in-house machine learning teams, but not really ready enough to invest a sufficient amount of funds to play the machine learning 2.0 game. So let's have a look. For these teams, is the question, how to answer this question. And the best way to do that is to look at the past, look at the future, see where we are now, and plan the actions, basically. Past, we all know what happened with AI in the past. Now, some people may disagree, but I actually think future is rather easy to predict. After all, we're all going to die in 100 years. Actually, we're all going to be dead in 100 years, and the sun is going to explode at one point. What is difficult to predict is actually the timeline. And actually, the timeline is what some people do for life. And I don't mean like ladies at fun fairs that are looking into the crystal ball. I think about the people who earn serious money by being able to predict the future, like investment professionals. So it is not an unattainable task, and if one wants to see what is coming ahead, they should just have a look at where the money goes. Not the VC money, though. You should be careful there. The past. So, back in the ancient past, when dinosaurs roamed the Earth, and when we all used to train our machine learning models from scratch, the procedure was basically collect the data, label the data, train the model, correct for error analysis, and deploy. And then basically monitor. If your distribution shifts, you have to, again, collect the data, label the data, retrain the model, and so on and so on. And they were basically narrow intelligence systems, very, very narrow, very specialist models. So this example that you're seeing now is actually from R&D in the BBC. Not many people actually know that after tennis, bird watching is probably the second favorite pastime of upper middle class, middle-aged British people. So hence, BBC has a show about it, and the show is called, it kind of runs for the whole year. It's called Autumn Watch, Spring Watch, Winter Watch, Summer Watch. And basically, there are a ton of cameras mounted at a certain location that record 24/7, and then after that is recorded, it comes to a studio where producers need to kind of sift through a lot of that footage and extract interesting frames, interesting scenes. So this is, I think, back a couple of years ago, has been a first example of really like live in production use of machine learning in the BBC. Right, so again, past, collect the data, label the data, train the model. Future, what will AI become? I think we can all agree that it's gonna be, that the artificial general intelligence is gonna happen. When I say general, I mean the systems that are able to generalize across tasks that they have not been trained on. So last year, I think, in October 22, there was a very interesting paper published by the researchers from Allen Institute. It's called Supernatural Instructions, where they actually show that the power of generalizability of the models grows with the number of diverse tasks the model has seen. So basically, in your instruct fine-tuning stage, when you're training your large language model, the paramount should not be the number of samples per one task, but the number of diverse tasks that you input. And I think one of the most surprising things about the large language models was actually that they are able to generalize so well. And this is just going to increase in the future, this ability, whether it comes from more data, more scale, or more clever algorithms, it's yet to be seen. And then another way how some people like to see the future of AI is as like another semantic layer, as a new operating system. And the person who is particularly in favor of this view is Andrew Karpathy, who is basically claiming that at the moment, large language models basically orchestrate already input, output, database access, browser access, and whatnot, and in the future, it's going to encompass and be much, much broader. But what is AI today? What actually is it today? If tomorrow is going to be AGI, if yesterday it was very narrow models, what is it today? This image here is a reference to a paper, very famous one from 21 called Stochastic Parrots. In this paper, these authors claim that actually large language models and GPT-like models are very good at mimicry, but they don't have any sort of understanding of the world. And surprisingly enough, from probably 2018 to last year, a huge amount of people have actually built their careers around this, on the back of this hypothesis. But, you know, I think we've all used GPT-4 long enough to know better, but if there is still some kind of convincing left to do that actually there is something really different happening inside these models, there is an evidence in the form of this paper, which is called Emergent World Representation, exploring a sequence model trained on a synthetic task. So what happened here, basically, the researchers took very, very small transformers and said, let's train it to predict the next move in the game called Othello. And this is a game similar to Go. So they had a certain number of moves, predict the next one, and so on, like a normal language model. When the model was trained enough, they said, let's have a look at the weights and let's see what the model has actually learned. And it turned out that at any given point in time, these models basically do have and do know state of the board without any directed effort for them to be taught this thing. And the second one, personally my favorite one, if I would really recommend this one, it's called Progress Measures for Grokking via Mechanistic Interpretability. So in this paper, they say, okay, well, let's take even a smaller transformer and give it a very simple task to add numbers modulo 113. Could anyone guess why 113? Yeah, it's still an open question, but there are a lot of hypotheses. So what happens here is that basically these numbers are given to the model as words, so there's no sense of arithmetic. So you have one number, second number, and target is the result. And when you look at the loss, it's obvious that the model overfits immediately, starts memorizing, but after a while, it performs very well on the test set, held out set. So again, looking at the weights, figuring out, doing very careful ablation analysis, figuring out what's happening inside the weights, it turns out actually that this model learns polar representation, a representation of numbers in polar coordinates, and then add them as a rotation of a unit circle, which is for me amazing. And this all comes from a very, data in, data out, data in, data out. So I think there's a lot that we still don't understand, but the architecture that we see should not be so easily dismissed as some sort of with some sort of stochastic parity hypothesis. Okay, going back. Present, probably very powerful systems, but what do we want to know, people like me working in mid-sized firms with in-house machine learning teams, is how is this technology going to affect our industry, and how is it going to affect the digital world in general? So from my point of view, I think these models will bring a completely new user experience and user interface for knowledge and information discovery. And we already see this. Klarna has recently partnered with OpenAI, and they claim that they will deliver a new user experience of the type. It's my 16-year-old son's birthday tomorrow. He likes books, science, not particularly interested in football. Can you recommend something under 40 pounds that's deliverable by tomorrow? And then you can iterate. No more tedious searches. And that's just only one part of the equation. The very, very exciting part comes when we start thinking about the recommendation systems. So back when the ChatGPT has been first released in November last year, I think internet was flooded with I asked GPT type of posts. So, well, to revive that trend, I asked ChatGPT, to recommend pieces of content, shows that are similar to True Detective. And anyone who's watched it probably knows that these are actually very good recommendations. That's okay, probably not very surprising. But what is surprising is when you ask it to explain, it actually gives a very, very good explanation of how it came to that decision. For example, complex characters, mystery and crime elements, dark and atmospheric tone, psychological depth, and so on and so on. So I do come from a finance background. I spent 6 or more years working in the asset management firm. And there, people who are investment professionals, when they want to invest in a particular asset or purchase particular equity, they would use mathematical models. But typically, they would not rely on XGBoost, random forest, deep learning, and whatnot. They would try to rationalize over price of an asset. So they would say, OK, there's a price of an equity, but I can break it down to liquidity, volatility, value, quality, and whatnot. So there are like 5 factors that they would take into account, and that they do think that they explain maybe 80% of the variance. But in return, you get a kind of a full explainability and robustness to error of these type of explanations. So the same is probably possible with pieces of content like this, dramas, where each and every piece of content could be described by the factors underpinning it, like genre, like mean age of actors, like tone, like production quality. And the reason why in past we haven't been able to think in these terms is because we didn't have the tools to do so. And in particular, I think that the recommender algorithms like collaborative filtering are in some sort, way, shape, or form, are factor models. It's only that factors are very rudimentary and non-explainable. So this is one thing. If you can explain your piece of content in terms of these factors, and you can explain a preference of your viewer, again, in terms of these factors, you can easily match, explain, and also include a kind of editorial guidance, if you have any. So this can apply both to news, to more like video type of content, and so on and so on. But how could one do that? And how did ChatGPT know about all of these like 7 factors that it explained here? Is it RAG? I'm not sure how many people know, but retrieval-augmented generation is actually now the most popular methodology how to extract value from the large language models. And GPT-4 actually has access to the internet, but it's not how it got this information. So if it's not RAG, if it's not getting this information from the outside, then it must be in its weights. So it means that the model, during its training stage, has seen a lot of maybe transcription of the content, maybe reviews in different corners of the internet, and came up to this conclusion on its own, kind of, in its weights. And I think since a month ago, people are actually coming to a realization that to be able to effectively use the information that you have to somehow put it in the weights of your model. And the best way to do that is to pre-train your own model, which is kind of expensive and difficult, and you need a big team and whatnot. So probably not feasible for tier 3 companies. And then there's another way that NVIDIA researchers have pioneered. It is called domain-adapted fine-tuning. So when we talk about fine-tuning, people just think. So when you train modern language models, there is pre-training, instruct tuning, and reinforcement learning from human feedback. So pre-training, in this case, what they've done for pre-training, they've taken open source model, Llama, and then they said, well, okay, this model has been trained on a large set of data, but we in-house have a kind of a different data. It's a bit niche, and this model has not seen our data. Let's continue training. So it's not fine-tuning, it's continued pre-training, where you actually have to be really clever how you mix your data. You cannot just chunk your data and continue training. You need to mix it with the original data and kind of carefully choose your learning rate, not to kind of cause some sort of catastrophic forgetting of your model, and then everything is ruined. So basically, the first step is that, domain-adaptive pre-training, and then in the second step, you go for instruct tuning. And apparently, this yields incredible results. And it's not only about, here the question is not only about the money, because obviously running something in-house could be much cheaper on a smaller model. It's inference time, it's data security, it's scalability, and everything. And basically, you have control of your own model, on your own data. You can retrain fairly easily once you have established this process. You can retrain every week when you have new data. It's like the cost is in probably thousands of dollars rather than in hundreds of thousands. And actually, if one can, for the people who are working in the field of retrieval-augmented generation, in this paper they say that even if you do a very tiny thing to train your own embeddings on your own data, it's going to increase the efficiency, the performance of your model of your system by 30%. So that was the one evidence of this methodology. And the second one, it's a little bit kind of a more hacky way to come to the same thing. The paper coming from a Chinese university that is kind of using both smaller model trained on proprietary data combined with the reasoning capabilities of GPT-4. So they do stick to RAG again, but using GPT-4, but just improving the context, basically, of that prompt. Okay, so RAG is a hack because when you have retrieval-augmented generation over your data, the model is basically not able to reason as efficiently and effectively as with the data that is in the weights of the model. It is like in the olden days, in the NLP, we had regex, and it was full of rules, and it was a bit clunky until we had these great models. Okay, so how does one build? How does one build with this knowledge safe machine learning tools to be used immediately, to be used efficiently, to be used in-house for maybe Search 2.0, Recommenders 2.0, or simply for an internal chatbot for your organization? Probably domain adaptation and instruct tuning is the first line that everyone should try. But then probably the golden goal would be to pre-train on model if there is enough in-house data. But at the moment, the knowledge about how to train these models efficiently is very scattered. It's almost like dark magic. How much data do you put in? Which data types do you put in? Some people say if you add code, it's going to increase reasoning capabilities of the model. No one's proved that. Some people say, well, you have to add toxic speech because if you don't, the model's not going to know what it is, and it's going to make blunders and whatnot. So it's a still very, very risky activity. And probably for the organizations I'm talking about, the previous approach would be better. But one should be mindful because some of the biases are already learned at the pre-training stage. And there's a plethora of papers talking about this. Actually, this year, the award-winning paper in the ACL has shown that the political bias acquired in pre-training cannot be removed afterwards. So you have to kind of live with it if you use it. Okay, one other probably pro for having a more constrained model is if you don't show it all types of data, it's never going to know about certain things. But as I said, it's a very difficult and a very lengthy process. So how does one approach it in-house? So we've said the situation at the moment is somewhat complex for the teams in the mid-sized organizations because you start working, for example, on low-hanging fruit, and then what do you know? Next GPT-4 release solves that problem for you, and all your work can be thrown away. So the focus of the problems you choose cannot be just kind of low-hanging fruits because you're going to be disrupted really soon. So you have to look further. But then if you look further and go with the domain adaptation, I think the problem is reputational risk. How are you going to deploy it? These models are not as safe as GPT-4, for example, that OpenAI has invested millions in safety research. So I think the recipe for here is wide input, narrow output. Again, going back to Search 2.0, Recommenders 2.0, you can interact with the system in natural language, but constrain the user experience on something more, more concrete, more controllable. Past, narrow specialist models, future, AGI, and today, I think the old world is dying, the new one struggles to be born, and we're living in the time of monsters. So one has to really tread carefully and be really smart in order to secure good projects and to make the right steps in the right direction. And with that, I'd like to open for questions.
Do we have any questions before I ask one? Well, my question, okay, sorry. Just wait for the microphone.
Good morning. It's working. You have mentioned catastrophic forgetting.
Yes.
Regarding that part, there are some new research regarding the incremental continuous learning on that one based on new data without requiring any full retraining on that one. Are you familiar with some of these, and how do you see these trends?
Yeah, that's exactly that. Domain-adapted learning, continued pre-training, what NVIDIA has done, and the others are doing at the moment. So basically, the rule of thumb is you have to kind of include at least 10% of the data from the original pre-training data set. But yeah, of course, you know, that's a must now.
Thanks anyway.
Thank you.
Any other?
Hello, Marcel. Yeah, sorry. Can I go? Yeah. Hello. Thank you for amazing talk, Marcel Tkaczyk, PwC Austria. We are also building solutions with Horak, basically. And I was just interested on, and we are also trying to do some fine-tuning with LoRa and so on these like GPT models to specialize it in some sort of like limited domain, like data privacy or risk management and so on. And basically, because you mentioned RAC, and you also showed these nice examples from ChatGPT, and you also mentioned that the knowledge seems to be contained in the weights. It's quite interesting because the examples that you shown are basically widely known, as you know, of the books, right? But if I ask it, for example, something about some TV series that are not that widely known, or the content of it, it just uses this autoaggressive process to make the stuff up. So I'm just interested in your perspective on this RAC methodology and so on. I also experienced that with RAC, it doesn't work that well if the content to be pulled is sort of the same, so there is not this diversity in tasks, let's say, as you said. Yes, so just your perspective would be very appreciated. Thank you.
I'm afraid I didn't understand that question. I'm so sorry. So you've asked me whether, like, you have to have, whether, could you please just summarize it very quickly?
Sorry, maybe it was too many things at once. I'm just interested in your perspective on RAC in general. How does it fit into this entire ecosystem in building solutions?
Yeah. I think even after you do domain-adapted pre-training and instruct fine-tuning, you still have to do RAG, right?
Yeah.
It's almost like a necessity now.
Yeah.
Because you want to make sure that, RAG is much easier in this way. Like you end up with the actually great context because you have a good embedding model. You end up with better reasoning capabilities. So I think the performance could be almost doubled in this way.
Yeah, okay, perfect, thank you.
Anybody else? My question would be, with what data are you feeding your system? Is this are you using the data collected by BBC journalists or the general data? If you're using the BBC journalists legally, you're covered. But if you're using it wider, then probably it opens some issues.
I think BBC can do anything. We have 23 petabytes of data. We have 120 billions of tokens. So we actually can pick and choose. But at the moment, we're experimenting with domain-adapted pre-training with our own data sets. So, because we want to build a model for us. So, yeah.
Okay.
Yeah.
Okay. If we have no further questions, of course, you can find Danijela around in the lobby if you have any other question. Danijela, thank you, and this is a certificate for you as a lecturer here.
Thank you.
Thank you, Danijela.
Thank you.